factorial equals 1. 0 factorial equals 1. So 1 factorial is equals 1. 0 factorial is also equals 1. Zero factorial is also equals 1. Of course, we will understand that when we have 1 factorial will mean 1 times 1. There's no, or better still, you know, if this is 1 times 1, 1 times 1 is 1. Now, but the problem now is, how did 0 factorial become 1, right? That's the problem. Don't ask me. Don't ask me. Why what? Oh, I'm supposed to know. What am I supposed to know? No. I'm the message I'm supposed to know, right? Even person will write and you confuse them. Okay? So I'm asking you to believe that 0 factorial is 1. You cannot believe. But if your pastor says it, you will believe. You don't do pastor thing. Are you serious right now? You're a Christian Catholic. Or if your father says something. They know to say something like that. No, they don't need to say something like this. They need to say something like, what did he say? What are you saying? Odo, I am game. Okay. Okay. Well, if your pastor says or your father says you are going to be blessed this week, is it before uncle? Oh, you believe it, right? He said you don't believe, you say amen. Right? So imagine. Okay, but you will say amen. What is the meaning of amen? Or we agree. You used to ask why. So if your pastor says you are going to be blessed this week, you'll be like, why? Why? Okay, that's nice. That's nice. Okay, so of course there is a mathematical proof that 0 factorial is equal to 1, but nobody's going to ask us that. So just know that whenever you see 0 factorial, it is equal to 1. Is that okay? Oh yeah, let's write. Let's write. Evaluate. Number 1. Evaluate 3 factorial times 2 factorial. Let's start very simple and then we go to more complex one later. They said evaluate 3 factorial times 2 factorial. Are we there? Now, what will you do? Oh yeah, pay attention and listen now. Pay attention and listen. Now, you would say 3 times 2. 3 times 2 is how many? So this is 6 factorial. Is that true? And then 6 factorial will be what? What is 6 factorial? 6 times 5 times times 3 times 2 times 1. Is that true? And then you multiply and get your answer. Is that right? Correct? But this is F9. Okay? If you do this, F9. This is not correct in any planet. It is not correct. Oh yeah? Let me show you the right way to do it. Listen and listen carefully. The reason why I showed you this is because that is the first thing that will enter your head. This times this, you will just multiply. 3 times 2, 6. And then you start breaking it down. But that is not how it is done. So, if I say evaluate this, break them down individually. Oh yeah? 3 factorial is how many? Times 1. Is that true? Times 2 factorial is how many? 2 times 1. Oh yeah? 3 times 2. 6 times 1. 7. 6 times 1. 7. Times 2 times 1. 3. Abi? Okay. Oh yeah, what is the answer? 6 times 2? Somebody said 8. And this is the correct answer. Please, this is wrong. Before you go and copy it as the answer. So this is wrong. You don't do something like this. Okay? So the answer is 12. You see that this answer and 6 factorial, are they the same thing? 6 factorial will be a very big number. 6 times 5 is 30. Abi? 30 times 4, 120. 120 times 3, 360. 360 times 2, 720. So 720 and 12, there is a big gap between them. Is that making any sense? Oh yeah, copy. And let's go to the next question. What unit do you want to put? Want to put your name? Want to put your name? Please write. Number 2. Are you ready? Number 2. Number 2. Number 2. They said evaluate. Let's say 4 factorial times 0 factorial. Evaluate 4 factorial times 0 factorial. Answer is 0, right? 4 times 0, 0. Right? But you don't have to do that. Oh yeah, let's break this one down. 4 factorial is how many? 4 times 3 times 2 times 1. Is that true? Times 0 factorial is how many? It is 1 because we said it here. Is that true? 4 times 3 is how many? 12. 12 times 2, 24 times 1 is 24, right? 24 times 1 will still give us what? 24. Are we following? Come and sit here. Come and sit here. Yeah? Come and sit here. Where's your bag? Come and sit here. Number 3. Number 3. Evaluate 4 factorial times 3 factorial times 1 factorial. Evaluate 4 factorial times 3 factorial times 1 factorial. I hope you know why I'm not going big numbers for now. Okay? Big numbers are more, they take more time to evaluate. Imagine I give you 10 factorial. 10 factorial is a big number, right? So let's just stick with small numbers. Okay. 4 factorial can be written as 4 times 3 times 2 times 1. Then times 3 times 2 times 1. Times 1 factorial is how many? 1. Okay. 4 times 3, 12. 12 times 2. This is 24. Times 3 times 2, 6. This is 6. 24 times 6 will give us how many? 144. 144. 144. Number 4. Number 4. Evaluate 2 factorial times 3 factorial times 0 factorial. Okay, still similar to that one we have there. Yeah, the first one. 2 factorial is 2 times 1 times 3 times 2 times 1 times 1, right? Yeah. Good. This would give us 2 times 6 times 1. That will give us what? 12. And we have 12. Making sense? Yeah. Okay. Number 5. Number 5. Number 5. Number 5. They said evaluate 4 factorial times 5 factorial divided by 5, okay, not 5 factorial, let's say 3 factorial divided by 3 factorial. 4 factorial times 5 factorial divided by 3 factorial. I have 4 factorial times 5 factorial divided by 3 factorial. Okay, so let's see how we could do that. So 4 factorial can be broken down into 4 times what? 3 times 2 times 1, right? Times 5 factorial is 5 times 4 times 3 times 2 times 1. All over 3 times 2 times 1. Now you can, of course, cancel out some certain things, right? 3 times 2 times 1 can cancel 3 times 2 times 1, right? Yeah. 3 cancel 3, 2 cancels 2, 1 cancels 1. You can do something like that. Oh yeah, let's multiply. 4 times 3. 12 times 2. 24. So we have 24 times 5 times 4 is how many? 20. Now when we multiply, we have 480. Is it 480? Oh, good. We have 480 as our answer. Understood? Number 6. Evaluate 8 factorial times 2 factorial divided by 6 factorial. 8 factorial times 2 factorial divided by 6 factorial. Now, listen and listen carefully. We could actually go and start breaking these numbers down the way we broke this one down. But there is a shorter method. And that shorter method does not involve saying 2 year 1, 2 year 3. Mba. Look at what the shorter method looks like. Let's break this guy down. 8 factorial is what? 8 times 7 times 6 times 5, so on, right? But I can stop at 6 factorial. Why am I stopping at 6 factorial? Because I have 6 factorial at the denominator. So times 2 times 1. I'm breaking this one down to this. Then all over 6 factorial. So that this one can just cancel this one. See that this one is much cleaner. And I have 8 times 7. 8 times 7 is how many? 56 times 2. And that will give us what? 112. This one is much more cleaner in the sense that we did not break this 8 down to the last. Because if you look at it, this 8 factorial that we have here will be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then times 2 factorial is 2 times 1. All over 6 factorial again. You will start 6 times 5 times 4 times 3 times 2 times 1. Somebody that is using this method has gotten the answer and already gone to the next question. It can never now evaluate here. Then, if you do this, what will you now start doing? You start cancelling. 6 cancel 6, 5 cancel 5, 4 cancel 4, 3 cancel 3, 2 cancel 2, 1 cancel 1. You now have 8 times 7, 56 times 2, 112. You still get the same answer, but this one is cleaner. So why did I stop at 6 factorial? Because it can easily cancel the 6 factorial at the denominator. Does that make any sense? Next question. So I would have also done the same thing here, but I just let us do it like that. Right. Okay. Number 7. Evaluate. Evaluate. Say we have 7 factorial times 3 factorial divided by 4 factorial. 7 factorial divided by 3 factorial. Sorry, times 3 factorial divided by 4 factorial. Let's do that. So, you can decide that you want to break it down to the last. Or you can follow me on this journey of short methods. So, what can we do here? I will have 7 times 6 times 5 times. Where will I stop at now? I will stop at 4 because of the 4 at the denominator. So I will say 4 factorial times. I can now continue breaking 3 factorial down. I can say 3 times 2 times 1. Then divided by 4 factorial. 4 factorial can cancel 4 factorial. Is that making sense? So if both of them cancel out, we can now multiply the numbers that are left. 7 times 6 is 42, right? 42 times 5 is what? 210, right? 210. So we have 210 times 6. 210 times 6 would give us what? 1260. Like this? 1260. And that is our answer. Is that okay? Good. Number 8. Number 8. Stand up from that place. Stand up from that place. Come and sit. Sit there. Sit there. Number 8. Evaluate 8 factorial times 3 factorial all over 5 factorial 3 factorial. Of course, this one is much more straightforward. Why is it much straightforward? Can 3 factorial cancel 3 factorial here? So both of them can cancel out. Both of them can cancel out. Because if you break down 3 factorial, it is 3 times 2 times 1. If you break down this one, 3 times 2 times 1. So they can cancel out each other. This one will murder this one. Oh yeah, let's go and break down 8 factorial. What is 8 factorial? 8 times 7 times what? Times what? 5 factorial. I will stop there, right? Why am I stopping there? Because of the 5. So all over 5 factorial. Can this one cancel this one now? Oh yeah, what is 8 times 7? 56, right? 56 times 6. 336. 336. Okay, number 9. Evaluate. Evaluate. And what did they ask us to evaluate? They said we should evaluate 9 factorial times. Okay, just 9 factorial divided by 5 factorial, 4 factorial. 9 factorial divided by 5 factorial, 4 factorial. Okay? Get me the answer. Everybody try it out. Try it out. I'm walking around checking what you're doing. Yes. He knew I would ask you to come forward. That was why he came late today. Right? Okay. Ndeyi del now. Ndeyi del ebeni. Where is the factorial? Where is the factorial now? Sure, you stopped at factorial. Where is this factorial symbol now? Kedebe asterisk one day. Kedebe 4. Itu full 4. Did you throw it away? Times 5 factorial. Can I stop at 5 factorial? Because I have this here. Okay? Now, somebody can also somebody can make that decision. It's choice. All over, I can have 5 factorial times, then break this one down. 4 times 3 times 2 times 1. Can 5 factorial cancel 5 factorial? It can cancel out. Oh yeah, let's start dividing bit by bit. 4 here 1, 4 into 8, how many? 2. 2 cancels 2 up here. Then 3 here 1, 3 into 6, 2. Then we have 9 times 7. What is 9 times 7? 63. Is it 63? You don't even know how to multiply. Which school do you, shut up your mouth. Cancel out how? You cannot cancel out. Okay, so what are you supposed to do? Okay, multiply everything, right? Okay, multiply everything and then do what? You get an answer. And then multiply everything and get an answer. And then do what? And then divide, right? Now, what is the difference between dividing before multiplying and then multiplying and dividing? From what you just said, you multiply everything and then divide, right? And then I now divided before I multiplied. 9 times 7 is 63. 63 times 2 is what? 126. No be waiting you get. You have 126. Then if somebody go and say, okay, 9 times 7 times 9 times 8 times 7 times 6, what would that give you? 3024. Are we here? Divided by 4 times 3 by 24. Are we here? What would this still give you? If it's Kabilim. Okay, number 10. Are you ready? Number 10. Get me the answer to this one. They said evaluate 10 factorial divided by 7 factorial 3 factorial. 10 factorial divided by 7 factorial 3 factorial. 10 factorial divided by 7 factorial 3 factorial. I'm going round. Dashing sweets. Yes. To people that are not using calculators. Everybody is having scientific calculator. Let's come on. How are you? Yeah, welcome. Where are you coming from? Transekulu. It's not too far. It's not too far. It's not too far now. New Market, Eba, Transekulu. Which side of Transekulu are you coming from? Phase 6. Which side? I don't know that side. One Guinea. A calculator key use like here. Lie. See the 120. The 120 here. I should carry my sheet and go, huh? Okay. Let's do that. 10 factorial, I can break it down to 10 times 9 times 8 times 7 factorial, right? I can stop there. Divided by 7 factorial. Then, this 3, I can break it down, right? To 3 times 2 times 1. Can 7 factorial cancel 7 factorial? 3 here 1. 3 here how many? 3. 2 here 1. 2 here 4. 3 times 4. 12. 12 times 10. 120. You see, no calculator. No calculator. I told you people something about this calculator. If you depend on it too much, your brain will just die. Your brain will not have any use again. Because everything you're doing will now be calculator. And it will be transferred to your generation. They will start using calculator in primary 3. Primary 3. Imagine your son or your daughter comes back home with math assignments or say, Mommy, calculator. Will it not shock you? And then you look at what they are trying to solve. 11 plus 2. 11 plus 2. And then, we'll look calculator. 1. Plus, where's the plus again, Mommy? Where's the plus? It's not hand you use hand. Number 11. Number 11. Number 11. Number 11. Are you there? Evaluate. Say we have 9 factorial divided by 6 factorial 3 factorial. 9 factorial divided by 6 factorial 3 factorial. Okay. Okay. That's good. That's good. Delor, how are you? No problem. Oh yeah, let's check the answer out. 9 factorial can be broken down to 9 times what? 9 times 8 times 7 times 6 factorial divided by what? 6 factorial times, we can break this one down, right? 3 factorial is what? 3 times 2 times 1. 6 cancels 6. Are we here? Good. And then 3 year 1, 3 year 3. 2 year 1, 2 year 4. 3 times 4, 12. 12 times 7 is what? 84. Is that understood? Okay, one more question, then we'll move to the next phase. Number 12. They said evaluate. They said evaluate 12 factorial divided by 10 factorial 2 factorial. 12 factorial divided by 10 factorial 2 factorial. Bam 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 bam. Okay, so answer is 66, right? How did we get that? 12 factorial. Okay, sorry, this is 12 times 11 times 10 factorial divided by 10 factorial. 2 factorial is what? 2 times 1. This cancels this. 2 year 1, 2 years how many? 6. 6 times 11, 66. 66. Okay, so that's awesome. Now let us move to where these things that we are doing so far, because all these things we are doing here is preparing us for something. Okay, it is preparing us for something. So what we are going to do now is we are going to go to that aspect, and then you will see where all these things can be applied. Understood? Oh yeah, let's write. Permutation. Permutation. Are we there? Permutation. Oh yeah, let's write down. Let's write down something very important. Right. Permutation simply means arrangement. Permutation simply means arrangement. Permutation simply means arrangement. Are we there? Full stop. When arranging items, comma, when arranging items, comma, when arranging items, comma, the number of items, the number of items, the number of items can be equal, can be equal, can be equal or less than. Sorry, let's leave that less than first. Can be what? Equal. Can be equal to the number of available spaces. To the number of available spaces. The number of items can be what? Equal to the number of what? Available spaces. Full stop. This means that each item This means that each item gets a spot. This means that each item gets a spot. This means that each item gets a what? Spot. Full stop. Full stop. Are we there? In another case, comma, in another case, comma, in another case, comma, the number of available spaces, might be less or greater than, might be less or greater than the number of items to be arranged. Might be less or greater than the number of items to be arranged. Might be less than or greater than the number of items to be what? Arranged. Full stop. Now, we said a lot. Let us explain. So, when we talk about permutation, what did we say permutation is, class? Permutation means what now? Arrangement. Now, permutation goes, sometimes you will see it together with combination. Okay? So, when you go to your master's book, you will not see only permutation. You will see permutation and combination. And then most times they try to, intertwine both of them. And that kind of creates confusion. So, but here, we'll finish considering this one then before we even mention this one in the first place. So, when we say permutation, permutation deals with what now? Arrangement. So, arranging things in any given space. So, we now said something important. That when you are trying to arrange things, there are multiple scenarios that can play out. For example, let's assume I have 3 balls. A, B, and C. I have 3 balls, A, B, and C. And the question is, I should arrange these 3 balls into 3 spaces. So how can I arrange these balls into these 3 spaces? You see that the first thing you have to note here is that the number of items, which is the balls, is equal to the number of spaces available. Meaning that everybody will get a spot. Last. Is that making any sense? Last, everybody will get a spot. So, I can say this one will go into this one. This one will go into this one. Then last, this one will now go what? Into this one. Or, I can change it again. I can say, okay, you go here. You go here. Then this one will now maybe go somewhere there. So, if the number of items is equal to the number of spaces, at least everybody will get a spot. But sometimes it will not be like that. Sometimes it might not be like that. In some cases, you will have more number of items and then fewer spots. So the question can be, how can I arrange 3 balls into 2 slots? In reality, that can happen. Imagine you are preparing for a wedding. You and your husband or you and your wife, you now plan. We are only inviting 100 people. You are inviting 100 people and then you now got small hall. And now told the person that is, the events planner, please, 100 seats only. They now put 100 seats. Then on the day of the event, 500 people came. How are you? They will lap themselves. How will you arrange 500 people in how many seats? 100 seats. How will you do that? You see that no matter how you arrange, 400 people will be standing. True or false? True. So there's a problem. There's a problem. Okay? And then, in another scenario, you are planning a big wedding. Say you are planning to invite 500 people. Okay? Or 1,000 people. Because you have friends, family members and all that. And then on the day of your wedding, something happened. People were not able to come. You were inviting 500 people, but like 50 people showed up. I will just tell the caterer, please pack that food into my car. Yes. Pack it into the car. I will just go to motherless baby's home. We'll do wedding there. Yes. Okay? If people I gave invitation did not come to come and eat the food, the free food, I'll just carry it, pack it inside car. I will tell my wife, please, honey, enter the car. We enter the car. We go to motherless. In fact, if we don't see motherless baby's home, we will stop at Holy Ghost. You know, front of Holy Ghost Cathedral. Front of Holy Ghost Cathedral. And bring her, come and see people will gather you. And you will have free wedding guests. Yes. What happened to the 50? They will follow me. Or better see, I will just carry bus and reach that place and say, please enter, it's my wedding today. Boss, any boss I see there, carry them, go there. If people are invited will not come, I'll go and load people now. Not be so it happened for Bible. Do you remember the parable of the wedding? You don't remember? Read Bible, no. Book, no. Wait till you won't read. Novel. Okay. So you don't remember the parable of the wedding? The man that invited a lot of people for his wedding, and then they did not come. So what did he do? He went out and invited all the strangers. Anybody he sees on the road, he will just invite them. And all of them came to the house and then wine and dined with him. You forgot the story? Do you remember it now? Okay, so that is exactly what I will do. So in arrangement or permutation, there are certain conditions or certain things that will happen. For now, we are going to start with the easier one. When the number of items is equal to the number of what now? Space. So we start with that one. Then later we'll now talk about when the number of items is not the same as the space available, or when the space available is not equal to just like that. Does that make sense? So write down as a subheading, permutation of items in equal spaces. 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 Are we there? Full stop. Full stop. Or sorry, you can underline that because that's a heading. Now, right. Consider the letters. Right. Consider the letters A, B, C. We are using capital letters. Consider the letters A, B, C. Consider the letters A, B, C. Are we there? There are total of 6 arrangements possible of the letters. There are total of 6 arrangements possible of the letters. There are total of 6 arrangements possible of the letters. There are total of 6 arrangements possible for the Guinea letters. For the letters. They are. Oh yeah, I want you to do this with me. I'm not just going to write and then you copy. We're going to do it together. Oh yeah, pay attention. Make sure your neighbor is watching the board. If your neighbor is not watching the board, I order you to mawayanya. Mawayanya. Mawalo mehanya. Beat that neighbor for me. But please check the size of your neighbor. If you are like this and your neighbor is like this, don't try. I will not even separate fights. Okay, now we are looking at the letters A, B, and C. And we said that there are total of 6 arrangements. There are 6 ways you can arrange the letters A, B, and C. But we don't know how. For us to know how, we need to write down all the arrangements. So class, look at the letters A, B, C. I want you to arrange them for me. Now, one arrangement is already A, B, C. Are we here? ABC is one arrangement. Can you think of any other arrangement? No, wait. Let's do it in order, please, so that we don't get confused. Oh yeah, another arrangement is what? A, then we swap B and C, right? We have C, B. So this is A, B, C. Then we have A, C, B. Now let's do B now. B, A, C. Right? Is somebody confused already? You are confused. Say I. Okay. Why are you confused? You don't even know why you're confused, right? You don't even know why you're confused, Abi. Just tell your brain or your reset now. Good. Now we have BAC. Which other arrangement can you think of that B? BCA. Which one is BBC? Where did you get BBC from? Now we have BCA. We have BAC. Now which other one do we have? CAB. Cab. Abi? What again? CBA. Now this is 1, 2, 3, 4, 5, 6. I dare you to give me another arrangement. A. Where is the triple? Where is the double A coming from? I dare you. In fact, what am I saying? You give me any other arrangements, 1 million naira for you. Even ChatGPT cannot give you another arrangement. Yes. Put the C this side. Waka with my leg. Any other arrangements of those 3 letters? Anybody? Any other arrangements? Is this TC? Is this TC? Which C? Which language is this? CBA. Okay. You know, get eye. Some have eyes, but cannot see. Okay. Now, don't worry. There's nothing to do. There's no other arrangements. It's not even possible. Okay. It's not possible. So there's no other arrangement. So how many arrangements do we have here? We have 6. We have 6 arrangements. Now, if I have the same thing, let's say XYZ. If we start writing down all the arrangements, how many do we get? It will be 6. Now, what if we now have 4 letters? A, B, C, D. It will be 8. Want to find out? Do you want to find out? It's not going to be 8, but let's find out. Okay, so first of all, A, B, C is one arrangement, right? Okay, think about another one. A, B, D, C. Swap that one, right? Then let's go again. A, C, B, D, right? You can do this, okay? Let's do something else again. A what? A, C, D, B, like this, right? Okay, what again? A, D, B, C, right? Okay, what again? Somebody is not even following. A, D, C, B. Are we sure? Are we sure we don't have it already? Now, you see, we are still on A. We are still on A, and someone is saying 8. And then you will now do the same thing for which letter? B. And then do it for C. And then do it for D. Are you not going to get tired? You won't get tired, Abi? You can continue doing it inside your book. Inside your book. Now, listen carefully. We are going to actually have a total of 24 arrangements. So, I'm not even ready to start writing it with you. So, if we have A, B, C, D, if you start writing and start arranging the letters differently and all that, you will get a total of 24 arrangements. Don't ask me how. You can start. If I increase the letters to maybe A, B, C, D, E, do you know we'll have more arrangements? We'll have more arrangements. Now, 30 guinea. Listen and listen carefully. Listen and listen carefully. Are you listening to me? The number of arrangements, any, or let me say, number of arrangements. Number of arrangements is equal to any factorial, where any is number of items. So there is a pattern. There is a pattern actually. So whenever you are trying to arrange any number of items, the number of items factorial will give you the number of arrangements. For example, how many items were we trying to arrange here? 3. A, B, C. And I told you the answer even before we started. I told you that you will have 6. How did I get the 6? 3 factorial. And 3 factorial is 3 times 2 times 1. Which is how many? 6. And then we have 4 items. I told you that the answer is how many? 24. Okay, can she wait there? 4 factorial. 4 factorial beginning. 4 times 3 times 2 times 1. Which is how many? 24. If you make it 5, only one goes 5 factorial becomes 120. If I increase the letters to 6, 720. Continuously like that. So you can continue writing the arrangement if you want to. Now, but this is the formula. This is the pattern. Please write this thing down. Write it down now. Okay. But before that, write this arrangement. So write this arrangement. Then you now write this formula down. You can say in general, or generally, let's say generally, comma, number of arrangements is equal to n factorial, where n is the number of items. But there is a but. There is a but. And what is that but? Let me write it down here and then we explain. Let me write it down here. Okay? That is NB notes. The NB note is that any items are distinct. What does the word distinct mean? What does distinct mean? Oh my God, English. What does distinct mean? Oh, different. Now they are different. So we are saying any items are distinct. So all the items are different. So here, A, B, C, they are all different letters. They are not the same letters. They are different. They are all different. And that is why this formula will work. But a situation where they are not different, they are similar, then we have to introduce that factor also. So we are going to look at it. What we are going to do is, have you taken this guy down? Take it down now. Okay, now. Sharp. Take this guy down. When you take this guy down, you write that note and then wait for me. Are we ready? Can we move on now? Can you drink it on? All these secretaries. Please make sure you write this thing down after writing that formula and that's it there. Okay, make sure you write this down. That notes, any items are what? Distinct. That means that they are all different. Mado. Oh yeah, I want you to come back to this arrangement because I cannot go and start doing that one because that one is too long. So let's do something that is shorter. Let's look at something that is shorter. Class, imagine I tell you that A and B are the same thing. Okay? That means if I just anywhere we see B now, we replace the B with A. Let's do that. So here, anywhere we see B, we put A there instead. So I'm going to clean here off and put A here. Please follow up, follow up. Stop that thing you are writing and follow. So this is B, okay? This is our normal arrangement. Now, I want to show you the power of when there is a repetition. Now, if I say that A and B are the same, meaning that anywhere I see B, remove B and put A. Okay, so here is B, but I'm replacing it with A now. Here is B, I'm replacing it with A now. Here is B, I'm replacing it with A now. Here is B, I'm replacing it with A now. Here is B, I'm replacing it with A now. Here is B, I'm replacing it with A now. You will see that there was repetition of an arrangement. Class, AAC. Is there any other AAC somewhere? Where's AAC again? Where's the third one? Are you seeing AAC now? AAC. So, AAC, AAC. Now the same thing. 1. You know that saying in Igbo, Welobu maene ewu akwia, and then wolewu maene obo. Unabu kwandi Igbo. Hey! Chineke. You people are those auntie. Utoba. Okay, she relax, yeah. Now, you know when they say wolewu maene obo, wolewu maene ewu. You don't know what obo is? The rope you use to tie a goat. Okay? And then wolewu maene obo is the same thing. In the sense that when they say use the rope and tie the goat, and tie the goat to the rope. Tie the goat to the rope. Tie the rope to the goat. Both of them are still saying the same thing. That is what you mean by that. Now, that is the same thing here. AAC, AAC, and AAC. It's the same thing. So this is one arrangement. One arrangement. Now, ACA. Is there any other ACA? Where is ACA? Fourth one. ACA, ACA. Together. The same arrangement. Another arrangement. So one arrangement, one arrangement. Now, what about CAA? So we have CAA, CAA. One arrangement. So total of how many arrangements now? 3. 1, 2, 3. We have 3 arrangements now. Just by making 2 items the same. So whenever 2 items are the same, the formula is going to change. Now, here, in this case, when any items are not distinct or are repeated, comma, we divide by the number of repetitions of an item. So, when any items are not distinct, meaning when all the items are maybe the same, then or are repeated, meaning that there are some items that are repeats. So in this case, A repeated. So we said that we divide by the number of repetitions of that item, of that particular item. So first of all, if I was asked, how many arrangements do I have for the letters A, B, C? In this case, A, B,